Hey, have you ever stopped to wonder what our future is actually going to be made of? Like the literal stuff? Well, today we're going to do something cool. We're diving into a university course outline to get a sneak peek at the revolutionary materials that are going to build our world. So the course we're looking at has this really academic-sounding title, right? Nanocomposites. You hear that and you probably think, okay, that's for some super specialist in a lab coat somewhere. But trust me, that is not the whole story.
Because, and these are the professor's own words, this isn't just about boring materials. No, it's really about the smart devices and the mind-blowing technologies that we're all going to be using in the years to come. See? Way more exciting.
And that brings us to the big question for today's explainer. What will our future actually be built from? I mean, the literal building blocks of tomorrow. And the crazy part is, the answers are being cooked up in labs right now.
Okay, so let's kick things off with part one, rethinking our energy. It makes sense, right? Before you can have all the cool futuristic gadgets, you gotta have futuristic ways to power them. And that's where material science steps in first.
And here's the huge challenge we're facing. We're getting pretty good at generating energy from new sources, but we desperately, and I mean desperately, need better ways to store it. This is maybe the biggest hurdle to a truly green energy grid.
So, what are the options on the table? As you can see, scientists are exploring a massive range of ways to do this. We're not just talking about a better battery for your phone. We're looking at storing energy as heat inside chemical bonds, using things like mechanical flywheels, and even exploring some really advanced nuclear options.
Now, within that huge field, the course really zooms in on a few key areas that are getting a ton of buzz. We're talking about finally unlocking the real potential of hydrogen energy, creating super efficient solar panels, and just making everything we build way, way more energy efficient.
And get this, it's not just about making power. These same nanotechnology principles are being used to tackle big environmental problems, like cutting down on pollution and even cleaning up our wastewater. It really is all connected. All right, on to part two. We're moving from powering the future to building it with materials that are, well, they're kind of alive. We are diving headfirst into the incredible world of smart materials.
Now, to get this, we have to talk about one key player, piezoelectric materials. That sounds complicated, but it's actually pretty simple. All it means is it's a material that creates an electric voltage when you squeeze it or push on it. It turns physical force right into electricity.
So how does that play out in a real device? Well, imagine a tiny sensor. Step one, some kind of pressure gets applied to it. Step two, that little piece of piezoelectric material inside generates a tiny electric charge. And step three, a computer reads that charge as a signal. And just like that, you have the basis for tons of smart sensors.
And believe me, it is not just about piezoelectrics. This whole field is just exploding with other smart materials. Things like polymers that literally change shape when you zap them with electricity, metal alloys that you can crumple up and they'll just pop back to their original form, and even these wild fluids that can go from liquid to almost solid in a split second.
Okay, so this all leads us to our third and final section, building with new rules. Because if you want to make all this advanced stuff, you have to start rethinking materials at the most fundamental level. I'm talking about their actual atomic structure.
You know, at the most basic level, it really boils down to this. On one side, you've got crystalline materials. Think of atoms in a perfect, neat, repeating grid. That's what gives them their strength. On the other side, you've got amorphous materials, where the atoms are all jumbled up and disordered, kind of like in glass. And both of these structures have really unique, really important uses.
But here's where it gets even cooler. We're moving beyond just how the atoms are arranged. The next big thing is cellular materials. And the best way to picture these is just to think of a honeycomb. It's incredibly strong and super lightweight, not because of what it's made of, but because of its structure.
And as the source material makes really clear, it's that unique structure that gives these materials, quote, many technological importance. We're creating properties here that you just can't get from a solid chunk of the same stuff.
And the applications, oh, they are all over the place. We're talking about using these structures for high-tech shock absorption in things like helmets. They're being used as tiny scaffolds in tissue engineering to help regrow human cells. And of course, for making these ultra-strong but feather-light panels for airplanes and buildings.
So let's bring this all home. Let's talk about the big takeaway, from the lab to your life. How does all of this incredible futuristic research actually make the jump from a science paper into something that changes your day-to-day?
Well, it happens in stages. Right now, a lot of what we've talked about is in that basic research phase, just like the professor's course covers.
But pretty soon, these experimental materials are going to find their way into the smart, efficient devices that are going to shape our world.
And if there's one thing you take away from all this, it's this. This isn't just some abstract theory from a university classroom. No way. This is the literal, physical foundation for the next generation of all technology. This is what's coming.
So I'll leave you with a final thought to chew on. We've talked about smarter energy, materials that can literally sense and react, and totally new ways of building things from the atom up. So, which of these technologies do you think is going to change your world first?